Welcome back to geometry. We're now going to look at the next two shapes, volume, pyramid, and cones. If we were actually in class, we could do an experiment where we compare a prism and a pyramid that has the exact same base. And if we build those shapes and fill them with sand, it would take us 3 pyramids to fill the prism when they both have the same base. So they are related by the pyramid is a third of the prism. So when we see that in the equation, it looks like this. Now remember, the base can be many different shapes. It can be a pentagon, hectagon, octagon, trapezoid. Whatever the base is, you do the area of the base times the height, and it doesn't matter if the pyramid is slanted. The equation is the same. So some examples of that. We notice in this case that the base is a triangle, 1/2 base times height. The base is 12. Multiply that times the height, which we notice is 9, and times a third. So we end up with 36 meters cubed for volume. If we take a look at this shape, the base is a hexagon, so we know we're going to use 1/2 SAN, but I don't have the apothem, so I need to find the apothem. And to do that, I want to take a look at the terrible triangle. Oof, that is terrible. So we want to take a look at the triangle that we make with the apothem and half of the sides. So this is going to be 6. I'm looking for A. In a hexagon, this angle is 360 divided by 2 times the number of sides. That gives me 30. So if this angle is 30, I might recognize the 30, 60, 90 triangle, which would give me the long leg of 6 times the square root of 3. But if we do trig on this, you would get the tangent of 30. And that is going to equal 6 over A, giving me an apothem of 10.39. So using 1/2 SAN, 1/2 times 12 times the apothem, 10.39 times 6. So the area, we had a small a for apothem. Now that we have a large A for area, 374. It's a real common mistake to think, done, because I calculated something. Actually, I calculated 2 things, but I'm not done because I'm looking for the volume. The volume is 1/3 times the base. Volume is 1/3 times the base, 374, times the height for 2494 centimeters cubed. So we can continue doing this. We can look for other missing things. If I look at this, what I don't have is the height. So I need to set up the equation slightly differently. In this case, when I set up the equation, h is missing. In blue, I have the area of the triangle, the base. And instead of calculate, I can do it either way. I can start moving things over to the other side, or calculate all of this out and then move that to the other side. 1/3 times 1/2 is 1/6. 1/6 of 12 is 2. I'm dividing by 2, and the height is 7. Lots of different ways that are correct to number crunch that. Another thing we need to remember is the volumes of 2 similar shapes are proportional, but they're proportional to the cubes. So we have to set up our proportions first. We want to look for 2 things that we have the same on both of these. I have the height of both. So 6 over 8 is 3 over 4. The proportion is 3 cubed and 4 cubed. And I know the volume of pyramid A, so I set that up. 96 times, this is 27, this is 64. For a volume of the smaller pyramid is 40.5 meters cubed. For another example like that, so I set up my proportions. For the scale factor, I like to simplify so I don't have to do 9 cubed. Here I have both of my terms are cubed. Then I do the proportions. 324 times 1 cubed is 1 divided by 3 cubed is 27. So the volume of the small pyramid is 4 meters cubed. The volume of a cone has a very similar equation. The difference is that the base is always a circle. A circle's area is pi r squared. Is pi r squared. So we have a very specific equation that we're going to use. It's still 1/3 the volume of the cylinder. We could do the same experiment with setting up the volumes and filling with sand. I don't have to have it be a symmetrical cone in order to use this equation with the height. So here we have it set up. The things we're plugging in are the radius and the actual height. And we start simplifying those. I have multiple steps here. And once I get it down to something times pi, 22.8 centimeters cubed. Another one setting up, same thing. 7 squared is 49. 49 times 13 divided by 3 is the same as multiply a third times pi. So we have 66.7 inches cubed. Cones are similar in the same way that prisms and pyramids are similar. As long as I'm looking at volumes of similar shapes, the volumes are proportional to the scale factor cubed, just like in pyramids, just like in prisms. So we set that up, and we do 9 divided by 3, simplify that. Set up our proportion. In this case, see pi, leave it alone. Keep it in the calculations, just keep pi like you keep x. It will simplify a lot better. And in this case, we have 15 over 9 pi. 15 over 9 simplifies to 5 pi over 3 feet cubed. Here we have another example. We set up our scales. I put d over c, that means 2 over 8, simplify to 1 over 4. Setting up my proportions cubed, cross, multiply, and divide. 4 cubed is 64. My answer is 6 pi centimeters cubed. We can also look at composite shapes. And if we're looking at the volumes of those, we're still going to set up. I want to find the volume of the cylinder, the bottom, and I want to find the volume of the cone, that's kind of like the roof. And in this case, I'm going to be adding them. I always think through what's the basic idea, and then I can set up the equations for each of those. Volume of the cylinder, pi r squared times the height. Volume of a cone, 1/3 pi r squared times its height. The heights can be different things. Then we number crunch those things, and we get 716.3 meters cubed. Another composite shape. In this case, it's the volume of the prism and the volume of the pyramid, and I add them. When I'm doing pyramids and prisms, length times width times height, 1/3. Length times width times height. No, it turns out that all of the dimensions on this are 6, so they simplify well. And we get 288 meters cubed. It's a little hard to see here, but we actually have a pyramid sitting on top of a prism. Both of them have bases that are triangles. So in red, I have the triangle. Base times height, and then 1/3 base, the triangle again, times height. Now for crunching those, we get 96 feet cubed. Another example of a composite, volume of the cylinder, volume of the cone. In both of these, we have the area of the circle times the height, 1/3 the area of the circle times the height. Simplifying those, 329.9 centimeters cubed. Okay, that's what we're doing. Your homework is on Google Classroom. PM me if you're having any issues. Have a good day.